Hey everybody, Mr. Reeves back with you today where we are looking at operations with scientific notation. Specifically, we want to answer the questions: how do you add, subtract, multiply, and divide using scientific notation? So I'm actually going to make two different videos. The first one on adding and subtracting with scientific notation, and the second one on multiplying and dividing. All right, so this first video, we're just going to add and subtract, which you might think is easier. But actually, adding and subtracting in scientific notation, like adding and subtracting numbers that are fractions, is actually more challenging. All right, so you may recall, hopefully you do, that a number written in scientific notation is either very large or very small numbers. At least that's what the intention for scientific notation is. And when it's written, a large number written in scientific notation will have a positive power of 10, and a small number written in scientific notation will have a negative power of 10. So that was the previous lesson, learning how to write them in scientific notation and understand numbers written in scientific notation. Now we want to do some operations. Like I said, we're going to start with adding and subtracting. All right, so let me just go ahead and go to, let's see here, my note paper. So we're going to, like I said, add and subtract numbers in scientific notation. But real quickly, let's do a review of something that I talked about before when I did my very first video on what a power was. Actually, I think I've used n instead of x. Okay, we said this entire thing is called a power, right? And we said that b is called the base, and that n is called the exponent, right? And this a over here is called the coefficient. All right. Now, most of the problems we were doing, the coefficient in those problems was 1. We did some raising power to a power problems where it wasn't, and maybe 1 or 2 here or there, but for the most part, our coefficient was 1. All right, but now we're going to be looking at numbers in scientific notation, and well, let's just write a number in scientific notation, and let me show you what I mean here. So if I were to write 3.4 times 10 to the 5th power, all right, this whole thing is actually a power. This is just this, which means each of these has a name. Well, the 5 is the exponent, the 10 is the base, and that 3.4, yes, you guessed it, that is the coefficient. That is the coefficient. All right, so it's the coefficient, that's my a, times the power of 10. And in scientific notation, the base is always a power. The base, is always 10. So this part is always a power of 10. All right. So if you want to add or subtract numbers in scientific notation, that power of 10 must be the same. So here we go. So the first thing we're going to write down is this. If you are adding or subtracting numbers in scientific notation, if you are adding or subtracting numbers in scientific notation, the powers of 10 must be the same. The powers of 10 must be the same. Again, it's like with fractions, okay? When you have to have a common denominator, that power of 10 tells you like how many zeros are coming at the end. And if you're going to add them together, it's like when you're adding decimals, they have to line up. It's the same kind of idea. All right? So if you're adding or subtracting numbers in scientific notation, the powers of 10 must be the same. If they are not the same, rewrite the coefficient as a power of 10 to create new numbers with the same power of 10. This is going to be the tricky part right here. Okay? This part right here is going to be tricky. It's like that part of finding the common denominator. I could say to you, if you're going to add two fractions together, they have to have a common denominator. If they don't have a common denominator, rewrite the fraction with a common denominator. It's easy to say, but doing it is not as easily done. All right, so then once they are the same, okay? If they are the same, I'll put this. When the powers of 10 are the same, when the powers of 10 are the same, add the coefficients and keep the powers of 10 add the coefficients. I should have said add. Sorry, guys. Woo! It's a good thing this is a video, huh? All right. When, I know that doesn't help you, that you can rerun the video if you were writing it down. When the powers of 10 are the same, add or subtract, right? Because we could be subtracting. Add or subtract the coefficients. There we go. Add or subtract the coefficients and keep the powers of 10 the same. Now remember, again, I keep going back to fractions because it's the same idea. Once you had that common denominator with the fraction, what did you do? You added or subtracted the numerator, right? But you kept the denominator the same. So this is like the denominator and this is like the numerator. All right, and then if necessary, after adding or subtracting, rewrite your answer in scientific notation. You're going, wait, we were doing everything in scientific notation. Why do we have to rewrite it in scientific notation? Here's the thing. When you do this step right here, step number 2, this tricky step, many times you have to take the number out of scientific notation. In fact, every time you'll have to take at least one of the numbers out of scientific notation if they don't have the same power of 10. So after you add or subtract, then sometimes you have to go back and rewrite your final answer in scientific notation. All right, so those are the 4 steps. Again, this is going to be the tricky step right here, but I, of course, will do several examples for you so you can learn and understand, just like when you first, whoops, what am I doing? When you first learned how to go away, yes, go away. That was not supposed to happen. All right, now I've lost everything. I am not starting this video over. I am not. I have put too much time into this video. Pay no attention to the man behind the screen. Where did it go? Oh no, where is everything? Come back. No. Ah, there it is. Whoop. There it is. Oh man, scary stuff. Sorry about that. All right, we'll see if that gets edited out of the video. Probably not, because it's late and I'm tired. Okay, so these are the steps. Hopefully you wrote them down because I'm going to now go back to the textbook and we're going to work through some examples, okay? All right, so what I'd like to do actually is start with one where, well, let's just look at the example in the book. If you look at these numbers, 3.1 times 10 to the 8, 3.38 times 10 to the 7th, and 1.1 times 10 to the 8th. If you look at the powers of 10, you will see that these two are the same, but this one is not. This one is not, right? So what do I want this to be right here? I want this to be 10 to the 8th, right? What do I have right now? I have 10 to the 7th. So do you guys agree from our work with exponents that 10 to the 1st times 10 to the 7th is 10 to the 8th times 10 to the 1st times 10 to the 7th? That will give us 10 to the 8th. Okay, so here's the tricky part, all right? As it's written in scientific notation, it's 10 to the 7th. So what I need to do is I need to rewrite this number as something times 10 to the 1st power. All right, which means I need to move the decimal one place. Now, when you multiply something by 10, it gets 10 times bigger. Do you agree? All right, so when you make this part 10 times bigger, you have to make this part 10 times smaller, okay? So this part is times 10. This is going to be really hard to see. So this part has to be divided by 10. All right, we're making this part here. Let me do that again, okay? This part right here is going to be times 10, right? We're writing it as 10 to the 1st power. So that part got 10 times bigger. So if I want it to be equal, this one has to get 10 times smaller. And how do you make it 10 times smaller? By moving the decimal one place to the left. All right, so let me explain that one more time because this is kind of tricky. What do we want? We want 10 to the 8th power, right? We want 10 to the 8th power. What do we have? We have 10 to the 7th power. So what do we need? We need 10 to the 1st power, right? So I had 3.38, but now I'm making it 10 times bigger by multiplying by 10. So this part has to get 10 times smaller, so I have to move the decimal over. So I get 0.338 times 10 to the 1st. Let me try that again. 0.338 times 10 to the 1st times 10 to the 2nd gives me 0.338 times 10 to the 8th. So, to sum it all up, I made the power of 10 10 times bigger, so I had to make the coefficient 10 times smaller. All right, I made the power of 10 10 times bigger, so then I would have to make the coefficient 10 times smaller. So now if I wanted to add these together, all right, the book is calling them multipliers. I call them coefficients. Now I need to add these coefficients together. And if you're not using a calculator, remember it's very important that you line up the decimal places, right? And we fill in the empty decimal places with zeros. And we would add all those together and we would get 4.538, right? And remember what I said, you add the coefficients and you keep the powers of 10 the same. All right? So that's how you can add those numbers together that did not have the same powers of 10. All right, so let's go ahead and take a look now at these problems in the textbook. All right, I'm going to start with this one down here. And the reason I'm starting with this one down here should be obvious. If it's not, let me make it obvious. These are the same. Well, if the powers of 10 are the same, just like if the denominators are the same on fractions, we can simply add, in this case, the coefficients together. In the case of fractions, you would add the denominators together. So I have 1.25 plus 0.50 plus 3.25. So I'm going to add those together. Again, I lined up the decimals. 5 plus 5 is 10, carry the 1. 3 plus 5 is 8 plus 2 is 10, carry the 1. And 1 plus 1 is 2 plus 3 is 5. So I get 5.0 times 10 to the second power. All right, and that should make sense because if we did a quick check, this right here is 125. Isn't that what that number is right here? This number is 50, and this number is 325. All right, because times 100 times 100 times 100. If we add all those together, what would we get? We would get 500, which is 5 times 10 to the second. Okay? All right, so in this case here, if you go back up to number 1, we have what? We have 10 to the 6th here, we have 10 to the 6th here, and we have 10 to the 5th, right? Okay, so we need, in this case, to multiply by 10 again, right? Now they put the 10 out here. I'm gonna change this a little bit for the way that I showed you. Oh, here we go. So this is going to be 10 to the 5th. All right, so that's just right there. Now, 2.25. What do I need to get 10 to the 6th, right? I need to multiply by 10 to the 1st. Do you guys agree that 10 to the 1st times 10 to the 5th is 10 to the 6th? I hope you agree, right? But I just made this 10 times bigger, so this one has to get 10 times smaller. I just made the power of 10 10 times bigger. Now what do I have? Now I have 10 to the 6th, right? So this must now become 0.225. All right? 0.225. I move the decimal one place. All right? So now what do I have? Now I have 4.2 plus 0.225 plus 2.8. These are my coefficients, all right? The book called them multipliers. I call them coefficients because it goes with what we said our powers were, okay? So I'm going to add those together, all right? And so again, I'm going to line them up. 4.200, 0.225, and 2.800. I add those together, I get 5. 0, 2, 0 is 2. 2 plus 2 is 4. 4 plus 8 is 12. Carry the 1. 5 plus 2 is 7. So I get 7.225 times 10 to the, what was it? 10 to the 6th, because remember, what did I do? I made them all powers of 6, right? Well, I didn't have to make these ones powers of 6 because they already were powers of 6, all right? Okay, so let's look at another example. I'm going to come down here to this one right here because this one is even a little more tricky. What do we have? We have 5, we have 4, and we have 2. We have 5, we have 4, and we have 2. Now, in the previous examples we did, 2 of them were the same and 1 was different, so it was pretty obvious that we wanted to make the one that was different the same. But we actually have a choice here, guys. We could make them all 10 to the 5th power. We can make them all 10 to the 4th power, or we can make them all 10 to the 2nd power. It's completely up to you. All right, but my recommendation's going to be if you go for the biggest one, then in the end, when you get your answer, it will be in scientific notation. If you go for the smaller one, you're usually going to have to convert it when you are done. Okay? All right. Plus, it goes with the way that I taught you. So we're going to make them all 10 to the 5th power. So I'm going to rewrite 6.25 times 10 to the 5th. That one is not going to change. Okay? Now this middle one here is 10 to the 4th, right? But what do we want? We want 10 to the 5th. So what do I have to multiply? 10 to the 1st. You guys agree that 10 to the 1st times 10 to the 4th is 10 to the 5th, right? But I just made it 10 times bigger, right? So this one must become, that's right, 10 times smaller. So I have to move the decimal one place over. So now what do I have here? Now I have 0.26 times, what is this right here? 10 to the 5th power. So this one is 10 to the 5th power now, right? And this one is 10 to the 5th power. Now I need to make this one 10 to the 5th power. So here we go. Okay. Now I have 10 to the 2nd. But what do I want? I want 10 to the 5th power, right? I want 10 to the 5th power. Well, what do you have to multiply 10 to the 2nd by to get 10 to the 5th? You have to multiply by 10 to the 3rd power. Do you agree? That will give me 10 to the 5th. Now, here's where it's going to be tricky. All right? I didn't make it 10 times smaller, right? I didn't make it 100 times smaller, or bigger, I should say. I made it 1,000 times bigger, so this one has to get 1,000 times smaller. All right? If you multiply by a power of 10, move it once to the left. If you multiply by 100, or 10 to the 2nd power, move it twice to the left. I'm going to have to take that number 1.9, and I'm going to have to move it 1, 2, 3 places to the left. Okay, and what do I get? I get 0.0019. I did not leave myself enough space. Here we go. Let me try again. 0.0019 times 10 to the 5th power. Okay, now they are all the same. Okay, I told you this was kind of tricky, all right? So now that they're all the same, now I can add those coefficients. 6.20, 0.26, 0.0019. That means I need to add 2 more zeros on here. Oh, but now we're not adding, we are subtracting. But the good news is the idea is the same. We line everything up, right? So can we do this? 0 minus 0 is 0. 0 minus 9. Oh, we're going to have to borrow. Okay, so I've told you before, you know, guys, it's okay to break out a calculator every now and then as long as you are doing the other parts of the problem for understanding. So just because of time here, I'm going to go ahead and use a calculator now. All right. So I'm going to go ahead and clear this out. So what am I going to do? I'm going to do 6.2 minus 0.26 minus 0.0019. And when I do that, I get 5.9381. 5.9381. All right, so that's what I would have gotten. I was going to do the whole borrowing thing and everything. I got to tell you, I'm a little bit tired and I'm not thinking super straight here. Okay, so I get as my answer 5.9381. And boys and girls, ladies and gentlemen, what is the power of 10? It is 10 to the 5th power. Okay? So to summarize, when we are adding or subtracting in scientific notation, all right, the powers of 10 must be the same. If the powers of 10 are not the same, rewrite the coefficient as a power of 10 to create a new number with the same power of 10. That's that tricky part, okay? Once the powers of 10 are the same, add or subtract the coefficients. Hopefully you won't have to use a calculator very often. All right. And if necessary, after adding or subtracting, rewrite your answer in scientific notation. We did not have to do that because when we were done, all of our answers already were in scientific notation. All right. This is something that practice definitely helps with, okay? I'll be making another video, I imagine, doing some problems from IXL for you, and maybe even a couple more problems from the textbook as well. But that's it for this video introducing adding and subtracting numbers in scientific notation. Until next time, have a great day.